Most privacy tools today are software-based. You install something, maybe tweak a few settings, disable some permissions, and just kind of hope your phone behaves. But this is different. This is PlugMate by TrustKernel. And it's not an app, it's basically a full Android system running on its own hardware, not inside your phone. Which means instead of trying to secure your existing device, it creates a completely separate one. I've been using this for a few days now, and I want to walk you through how it actually works, how you set it up, and why the architecture behind it is interesting. Before we plug it in, quick look at the device. It's almost the same size as a regular USB pen drive. If I compare them side by side, the footprint is almost identical, just slightly thicker, and the body is metal so it feels solid, not plastic, not flimsy. It also comes with this small USB-C extender and this casing. This is actually more useful than I expected. Instead of sticking straight out of your phone, it wraps around the back. So when you hold the phone, it feels much more natural. Alright, let's set it up. Setup is actually simple. If you're using Android, download the PlugOS app from the Play Store. If you're on iPhone or iPad, download it from the App Store. It also supports macOS and Windows through the Companion app. Once installed, you just plug this in. On some Android phones, you might need to enable OTG in settings, then register your device. When adding a device for the first time, you will be prompted to enter a product key. You'll find that inside the box. Enter it, and then it loads into a normal Android setup screen. Just complete the usual Android setup. Wi-Fi, preferences, whatever you normally do. And that's it. After that, whenever you connect it, it boots directly into its own Android environment. But this same device works on iPad, iPhone, and PC as well. It works with any device, so I can use it on the go. And this is important. This is not screen mirroring. It's not remote desktop. The processing is happening inside this small hardware. Your phone is basically acting like a display and keyboard. And honestly, it doesn't feel slow. Apps open normally. Scrolling is smooth. Multitasking works. It feels like using a regular mid-range Android phone, which is kind of impressive considering this is basically pen drive sized. I installed some real apps to test it properly. For example, WhatsApp Business. I can use it completely separately from my main phone, send messages, share files. Everything works like normal Android, but it's isolated, and that's the key thing. This is where it becomes practical. I can unplug this from my phone, plug it into a tablet or laptop, and I'm right back in the same environment. For example, if I'm using WhatsApp inside PlugOS, I don't need to set it up again. All my chats and apps are already there. No syncing, no relogin. The environment literally moves with the hardware. And it's not just WhatsApp. The same applies to any app I install here. For example, Instagram. I'm showing this mainly to demonstrate performance. Scrolling is smooth. Stories load normally. It doesn't feel like I'm running Android from a pen drive-sized device. It even uses the host camera. You can scan QR codes, take pictures, so from a usability perspective, this is practical. It's not just a security experiment. Now let's talk about one of the core features, the built-in firewall. This isn't a third-party firewall app. It's integrated directly into PlugOS, which means every network request goes through this layer. You have blacklist mode and whitelist mode. Blacklist means everything works unless you block it. Whitelist means nothing gets internet unless you explicitly allow it, which is obviously stricter. There's also live network logs. You can actually see which apps are trying to connect out, what domains they're hitting. That part is interesting, because normally apps just connect silently in the background. Here, you actually see it. Let's say I install a random free app. Normally, I wouldn't know what it's doing in the background. Here I can open network logs and watch connection attempts in real time, and if I don't like it, I just block it, and the app simply loses internet access. That level of control is rare at system level. You can even control DNS and restrict system apps from network access. Another small but important detail. PlugOS can block screenshots and screen recording attempts from the host device. If the host tries to capture the screen using normal screenshot API, it just blacks out the content. So that adds another layer during active use. There's also built-in mock GPS. You can use your real host GPS or manually set latitude and longitude. You can literally pick a location from a map, and apps inside PlugOS will treat that as your real location. Same with mobile network identifiers. You can simulate operator name, IMSI, network type. Instead of exposing real hardware identifiers, you control what apps see. And that's not necessarily about hiding, it's about compartmentalization. Let's say you're traveling or testing region-based apps. Instead of exposing your real location every time, you set a controlled one. Apps inside only see what you decide. Now let's talk about the more extreme security features. There's something called self-destruct. If you enable it and set a number of wrong password attempts, once that threshold is reached, the device wipes itself. Encryption keys are destroyed, data becomes unrecoverable. Then there's duress lock. If someone forces you to unlock the device, you enter a pre-configured password, and it wipes silently. These features are clearly designed for higher risk scenarios. Not everyday usage, but they're there if needed. There's also a toggle for Google Play services. The base system is built on AOSP. Google integration isn't forced. With a single toggle, you can enable or disable Play services depending on what you need. That flexibility is nice. Hardware-wise, it runs on a MediaTek G80, 8-core CPU. For this use case, it's more than enough. This one is 4 GB RAM, 128 GB storage. There's also a 6 GB, 256 GB version if you want more headroom. It includes normal sensors, gyroscope, accelerometer, orientation sensor. And importantly, your host device cannot directly access PlugOS storage. The storage physically lives inside this hardware, which brings us to the architecture. Now this is where it gets interesting. Because up until now, everything I showed you could still look like just another Android device. But the real difference is under the hood. Your phone or laptop, whatever you connect this to, is basically acting like a screen and keyboard. That's it. It's not running the apps, it's not storing the files, it's not managing the memory. All of that is happening inside this small hardware. And that distinction matters, because normally, even if you install a secure Android ROM, it's still running on the same physical phone. Here, the boundary is physical. Your host device cannot directly read PlugOS memory. There's no shared RAM. There's no direct file system access between the host and PlugOS. Even if your main phone gets compromised by some malicious app, it cannot just browse PlugOS files, because the files physically live inside this hardware. Now inside this hardware, there's something called a secure element. Think of it as a tiny vault. It's a tamper-resistant chip dedicated only for storing cryptographic keys. These keys are what protect your encrypted data, and here's the important part. Even the Android system running inside PlugOS cannot just extract those keys. It can request operations, but it cannot dump the raw keys. So even if the Android layer had some vulnerability, the core secrets are isolated. Then there's something called a Trusted Execution Environment, or TEE. This is a secure part of the processor. Sensitive operations like authentication, key management, encryption handling, all run inside that secure area, separate from the normal Android environment. So you don't just have Android with security features. You have hardware-level separation inside hardware-level separation. And then on top of that, all storage is encrypted by default. Every file written to disk is encrypted. And those encryption keys are tied to your authentication. If someone steals this device and tries to extract the storage chip, what they get is encrypted data. Without the correct credentials and internal keys, it's unreadable. Another interesting detail is the boot process. On many devices, the system loads and then it asks for your password. Here, authentication happens very early. If authentication fails, sensitive components never fully initialize, which reduces the risk of certain low-level attacks. So when you combine all of this, physical isolation, secure element for key storage, TEE for sensitive operations, full disk encryption, early authentication during boot, it's layered. Not just one security feature, multiple layers working together. And that's really what makes this different from just installing a privacy-focused ROM. A ROM still runs on your main phone. This is physically separate. It's not just software hardening. It's hardware separation. And that changes the threat model completely. So who is this really for? If you care about privacy, if you don't want everything on your main phone exposed 24/7, if you don't like constant tracking running in the background, then this kind of physical separation makes sense. For me, the biggest advantage is flexibility. I use both Android and iPhone. Instead of carrying separate work and personal devices, I can just plug this into whatever I'm using and instantly have a completely separate environment. No flashing ROMs, no replacing my main phone. Just plug in, and it's isolated. That's the concept, and honestly, this isn't some gimmick. It's a genuinely useful device for people who care about privacy and real separation. The link is in the description. It's available in 2 storage options, so you can choose what fits your setup. I've also included a coupon code, ORailNor. Use that to get an additional discount, so make sure you use that link. If you're serious about adding a physically isolated Android environment to your setup, this is definitely worth looking at. Let me know what you think about this approach, and I'll see you in the next one.